in week 2, we had seen what is a set and we had seen what is a subset. We took a few elements from the set and we formed what is called the subset. It was a substructure, right? Then we moved ahead and we studied graphs. We particularly selected a few vertices and a few edges from the original graph and formed what is called the subgraph. We had a graph, we got a subgraph. We had a set, we got a subset. Now, we have discussed what are groups, right? We can also tell here what is a subgroup. We can form a substructure and also define what is a subgroup. It holds true here too. Let us see more about this. We know that R plus is a group. Real numbers under addition is a group. Now, integers is a subset of R. We all know that. Now, integers if I take and if I give a plus operation to it, closure satisfies here, associativity satisfies, identity exists which is 0 and inverse also exists, right? And hence under the addition operation, Z plus is a subgroup of R plus. If you're understanding, well and good. Otherwise, please listen. All 4 properties hold true here. It was a plus sign of the group, right? We were doing a plus operation, addition operation on R and we saw that it is a group. Now, I took a subset of R. I'm giving the same operation to it. What do I observe? All the properties hold true. Please note, identity here is the same as the identity which was in the original group, right? And hence, I can tell that integers under addition is a subgroup of R plus. Now, let us see the formal definition of a subgroup. If G, star is a group, it is a binary operation and H is a subset of G. I took a group and I take a subset of G. Then H is said to be a subgroup of G if H, star is a group, right? Now, I take a group, I take a subset and I say that H forms a subgroup if it is given the same binary operation as the original group. This is the formal definition. Now, please note, whatever operation you are giving on the group, it must be the same on the subgroup as well. So, group and subgroup must have the same operation. Or, I can also tell it as subgroup must be given the same binary operation which is there for the group. It cannot be different. Now, Z plus is not a subgroup of R under multiplication. We cannot compare like this. Why? Because R has multiplication and integers have addition. But it is a subgroup of R under addition. This holds true, right? We have seen that. Now, it is also a subgroup of rational numbers under addition. Why? You can probably see the 4 properties, write it down and you will be able to verify it yourself. Also, rational numbers are a subgroup of real numbers under addition. Both of them under addition, right? Now, we have seen all this for addition. Let us see for multiplication. Z under multiplication, well, it is not a subgroup, right? And then under multiplication, Q is a subgroup of R under multiplication. Why? Because in Q you have inverses which are there in R as well. That was the only concern why integers were not a subgroup. We see that Q under multiplication is a subgroup of R under multiplication. Well, these were some of the examples of subgroups.